Hi all, welcome back to my lecture series. This is Muthuminal, Assistant Professor at the Department of Agricultural Engineering from SNS College of Technology. Today we'll see the continuity of the previous lecture series, that is the topic under water resources under the unit impacts of climate change due to water resources under the subject climate change and adaptation for the students of final year 7th semester. Let us have a small recap at the previous session what we have seen under the previous topic. What we have seen initially has been what is climate change, what happens or is the major cause of climate change, that is human activity and natural causes. We have specifically seen something about the impacts caused by agriculture along with the impacts caused by forest. Today we'll see how well the water resources are impacting the climate change. I have shown you a present carbon cycle initially. Let us have a small recap here. What happens in the sense under the terrestrial vegetation, due to the plant growth and decay, the ratio has been in a cyclic motion that reaches from 60 to 121. Again, it gets degraded to 60 and again it gets increased to 121. This is a cyclic motion. Under the soil and organic matter, this happens due to the land use changes which reaches under 60 percentage to the atmosphere. Then the exchange of soil and atmosphere happens at the land use changes with the cyclic motion of 1 to the 5 to 0 to 5, and next one will be the fossil fuel and cement production that results in the fossil fuel emissions will be 5 to 5 ratio, and it contributes to about 4,000. The next one is how well the carbon cycle contributed at the coal deposit, that is it comprises of 3000. Next one is oil and gas deposit that comprises of 300. All together will be reaching up to the fossil fuel emissions of 5 is to 5. Here, next one, as here I have shown you a ozone atmosphere exchange. This exchange will also happen in a cyclic motion, that is from 90 to 92. Initially, the cycle will be starting from 90 and then it reaches up to 92. Then again it gets degraded up to 90. And here you guys have to know what is comprising here. The dissolved organic carbon is comprised of about 700. The gas hydrates and the marine sedimentary rocks will be comprised about 66 lakhs to the 10 million, and then the marine organisms and the surface water will comprise about 2020. The immediate and deep water 38,000 to 40,000, and the surface sediment is about 150. This is the graph I have to show you the human activity influence due to the carbon contents. Here, the initial first top right corner, what I have shown you is nitrous oxide concentration. This has been due to the radioactive forcing of about 0.15 and the precipitation here as I have shown until 310. And for the purpose of CO2, carbon dioxide concentration, which has been shown at the left side of the top corner, shows you that the radioactive forcing is up to 1.5, which is 100 times greater than that of the nitrous oxide concentration, and the precipitation level of nitrous oxide is 310, whereas the precipitation level of carbon dioxide is 360. The next one which we have to concentrate on is methane concentration, that is shown at the left bottom corner. The radioactive forcing is of about 0.50, which is more than that of nitrous oxide concentration, and the precipitation level of methane concentration is 750 ppm. And the next one which you guys have a greater influence is sulfur dioxide. Sulfate aerosols get deposited in the Greenland ices, and the precipitation level of the sulfur aerosols is 200, and the ratio is lesser than that of the nitrous oxide concentration. Here I have also shown you the concentration emissions from the United States and Europe, and you guys have to know how well the human activity is get influenced here. This is the variation of the temperature on earth. Here, the departures in temperature in degrees Celsius has been shown for the past 140 years globally. And as you guys can see here, the direct temperature reaches about 0.4. And in the from 1961 to 1990 average, along the past 1000 years, at the northern hemisphere alone, the precipitation is about 0.6. The difference in color, that is direct temperature and proxy data, has been given in red and blue color, as you guys can see here. So this is what I have prepared for today's class. If you guys have any kinds of doubt or anything, you guys can ping me anytime. We will continue this topic at the next classes. See you at the next class. Thank you.